Okay, so yesterday we left off right here. I asked you to take problem number 11 and number 12 and graph those up. We actually came up with the functions we were graphing, and hopefully we recognize that the vertex, by looking at the vertex here, we get -3, -1. We plot that right there.
Oh, I actually had it.
Okay. We then look at our A value is 3, so we go over 1 up 3. We go over 2 and up 4 times 3, which in this case would be 12, but that wouldn't fit it if we're going up by single units. Therefore, if I'm drawing my parabola in, I'm hitting those points, then bouncing back up. Now, what is wrong with my graph right now?
It looks like a V.
Good. It looks, well, yeah, there's no arrow over here, but it also looks like a V. You're not allowed to have V shapes in parabolas. Okay? You need to round that off. So, round off the bottom. Make sure you actually hit it accurately at the points. Put your arrows on. At the end, maybe just kind of put a curve at the bottom. Make sure it's not a V shape. Make sure you don't have double lines in there and that kind of stuff. Okay? How many got that one?
I did.
Well done. So number 12, you're asked to graph that one, the vertex on this one. What is our vertex? Volunteer, please. Raise your hand. Yeah, Bailey. 3, 5. Okay, so yes, we look at the 3. Remember, it's the opposite, or what makes that 0. It's 3, and then 5. So 1, 2, 3, 1, 2, 3, 4, and 5. This graph opens down because of the negative. Okay, and so it's down. We're going over 1 and down 1/2. Remember, since it's really close to 0, that's going to be a really wide graph. We go over 2 and usually down 4, but since we're multiplying by 1/2, that puts us back at 2. And then over 3 and down 9, but since it's times 1/2, what do we have to do? Yeah, we got to go 4.5. Yeah.
Come on now.
And reflect it. Okay, and we go over 1, 2, 3, 4, and down how far usually? 16. But since it's half of 16, we'd actually go down 8. All right. Then we make sure we go through those points. I want you to tell your neighbor how you did on that one.
No, I didn't get it right, alright? Did it wrong.
Okay, if you didn't do it right, tell your neighbor what you did wrong.
Wrong vertex.
All right, raise your hand if you understand how to graph using patterns. What we just did in terms of the patterns. Okay, if you're not using patterns, then after you find your vertex, you need to create an XY table. Okay, and in that table, you're going to put your vertex in the middle. So that 3, 5 we have, that goes right here. And then you need to pick a couple points, so 2 points on both sides of the vertex. So you pick maybe 4 and 5 and 2 and 1. Okay, you put in your equation. Remember, we've shifted this one or changed it up, so we need to use this function here. So we have -1/2 x minus 3 squared plus 5. So you'd have to plug in those values. I'm not going to plug all of them in, but if I put 4 in, that's -1/2. And we'd have 4 minus 3 squared plus 5. Notice the only thing I replaced there was the x value. This value right here, I put 4 in for x. Okay, so 4 minus 3 is 1, squared is 1, times -1/2 is -1/2, plus 5 is 4.5. Okay? And then we go through that same process. But you got to make sure you do the order operations on that. Remember, this value, if this is our vertex right here, if we label with like a B, this value and this value are the same. They're symmetrical. It's that point right there and that point right there. Okay? Yeah. Okay, so if I were to calculate 5, we go through the same process, negative 1/2. It's just this time it's a 5 right there. Minus 3 squared plus 5. I realize the big idea emblems in the way there, but I think we get it. Okay? All right. Questions on it? All right. What would this value be right here?
That would be
Uh-oh. What's 5 minus 3?
2. 1.
2 squared. 4 times negative 1/2. Negative 2 plus 5. 3. All right. That 3 would match up with that 3 up there. Okay.
I did.
So switch over to page 263. Determine whether it's odd or even, or neither. Okay, odd functions do this. If I take f of x, or excuse me, if I find f of negative x, which is the first thing you always need to do to determine if a function's odd, even, or neither. You need to find f of negative x. What does that actually mean? It means that you take wherever you see an x in your equation and you put negative x. So you plug that in right there. When I do that, I get 5 times negative x, which means f of negative x is equal to negative 5x. All right. So if a function is even, so you can even put it up in your notes up here. If it's even, f of negative x will be the exact same as f of x. So in other words, after I plug in negative x, I'll get the exact same thing I started with. Is negative 5x and 5x the same? No. This is not an even function. So this one is not even. Okay? Well, it could be odd or neither. To know whether it's an odd function, you have to calculate negative f of x as well. Okay? Negative f of x says I take and I put a negative sign in front of the whatever f of x is. So f of x is 5x, and I put a negative sign out in front. Okay? So f of negative f of x is this is negative 5x. Okay? If f of negative x equals negative f of x, then it is an odd function. Yes. Is f of negative x and negative f of x the same? Yeah, they both equal negative 5x. So this is odd. Okay? If neither of those happen, then it's neither.
Cool.
Okay, hold on one second. So before we go any further out, you have to try number 4. Figure out what f of negative x is on number 4. Okay, f of negative x, we got to put negative x in wherever we see x. So I'm going to set it up like this. And all those places where there was an x, I'm going to put negative x. Negative x there, negative x there. Okay? What's negative x times negative x? Positive x. So we get negative 3x squared. So it doesn't change it. What happens here? It's negative x times 2. Negative 2x plus 1. So f of negative x is it the same as f of x? Does that match up to that? No. So that means it is not, it's not even. Okay. Everyone needs to figure out what negative f of x is. Are you doing this? Yeah, I won't help you right now. I'm teaching. You should be doing this right now. Like pause for a minute. Hey, I'm going to put a negative sign out in front. And then, so the only difference is I'm taking whatever f of x is, this thing up here, and I'm putting a negative out in front. So I have negative 3x squared plus 2x plus 1. That's what f of x is. And I'm multiplying it all by negative 1. So that changes all my signs. That becomes 3x squared minus 2x minus 1. Okay? Is this the same as that? Nope. This is not odd. It is neither. Okay? Guys, on the previous page of, if you look back to page 263 of your student journal real quick, take a look at that. On page 263, it talks about what an odd and even function is. Okay? So on that one it says, if it's an even function, it's symmetrical about the y-axis. In other words, it's symmetrical over the y-axis. Okay, if it's odd, it's symmetrical about the origin. Two things are changing. F of negative x equals negative f of x. Here, one thing changes. Okay, that may not mean as much to you right now, but when you start looking at the graphs, it'll make a little more sense as well. So when you encounter those on your assignments, make sure you talk to me if you need help. Okay. Hey, ladies and gentlemen, a couple of you have asked me about the graphs of odd and even functions. Hey, let me make if they give you a graph of an odd and even and ask you if it's odd and even, it's really easy. If you can fold the graph over the y-axis, if you can reflect it over the y-axis perfectly, like this one, the line of reflection is the y-axis, that is an even graph. Okay? If you cannot, then it's either an odd or a neither. The way you tell if it's an odd is you can rotate it about the origin. So here's the origin. Right there. This graph, if I spin it, it'll match up on itself again. Everyone understand what I mean? Okay, if I rotate it, so like if I turn my book upside down, it looks exactly the same. I've rotated it 180 degrees. That is an odd function. That's how you tell graphically if it's odd or even. That means number 15 is what?
Neither.
That one's neither. 16. Even.
Odd.
Am I rotating about the origin?
No.
Nope. That one's neither. How about number 18? That one's neither. Y-axis is here. Okay? Hey, there's some other patterns with the equations you can start looking at that has to deal with powers. Like if you have an even power and an odd power, a second and a first degree, that means it's going to be a neither function. It's going to be neither odd or even. If you have just an even power, that means it's an even function. Okay, if you have just an odd power, so like on number 10, that's going to be an odd function. If you have both even and odd, it's neither. That's another way to look at these. Okay?